Okay, so lesson 25, all about absolute value. This is our last new material for the year. And in case you're wondering, that's my buddy Eric fishing up on the Ausable River by Lake Placid, New York. And I just love the quality of the lens that took that picture. That's a fraction of the picture, but it almost looks like a painting. And that was taken with a Voigtlander 50 millimeter or 65 millimeter, I'm not sure, at f2 if you know anything about apertures. And look at the stunning nature of that photo. God, I love that picture. Anyway, let's see what we're going to cover for today. Today we're going to review simultaneous solutions to equations graphically and algebraically. We're going to do a little bit of past content questions, and then the biggie, we're going to introduce our last two concepts for the year: absolute value equations and absolute value inequalities. So, without any further ado, let's get started. Okay, so we're going to solve the following system of equations graphically. Let's do a little stop and start here. Apparently, I already put one of the lines up for you because I did not animate it properly, but go ahead, solve it all out, and I'll put the correct answers up. You can do stop and start on your end. Go ahead. Okay, so the first equation, negative x plus y equals 2. Got to get it to say y equals, so I add x to both sides, and I get y equals x plus 2. Remember, the slope's the number in front of the x, the y-intercept, the b is at the end, so the slope, how you move, is 1, and the y-intercept, where you begin, is 2. The next one's already in the correct form, so we know right away that the slope, being in front of the x, is negative 2, and the y-intercept is 8. Again, m for slope because it's how we move, b for y-intercept because it's where we begin. So let's graph the blue line, and as you can tell, I've already begun at 8. That's the y-intercept. But you know what? Take a step back. Let's do the red line first. The y-intercept of the red line, where we begin, is 2, and the slope is 1. So it's up 1 over 1, up 1 over 1, up 1 over 1, and there is connect a dot. So the red line is a picture of every single pair of points, every coordinate pair. That satisfies the equation, negative x plus y equals 2. If it is not on that line, it does not satisfy that equation. Okay, now we do the blue one. We touch at 8 because that's the y-intercept, and we go down 2 over 1, down 2 over 1, down 2 over 1, and we connect the dot, which we already did. Now, the one thing we don't have here is the answer written out, but that answer is 2 comma 4. I think it pops in at the end. So if it's 2 comma 4, that means x is 2, y is 4. Substituting into the first equation, a 2 for x and a 4 for y, I get negative 2 plus 4 is y, is 2. 2 equals 2, check. And y equals negative 2x plus 8. Let's substitute in a 2 for x and a 4 for y. Does 4 equal negative 2 times 2 plus 8? It does. I don't know why the 4 suddenly changed into a 5, except it was probably from the last one. But 4 equals 4, so that's a check. All right. And there's my point, 2 comma 4. Okay, so there's solving a system of equations graphically. Now we're going to solve a system of equations. I don't know why it says inequalities, but equations for the variables. You know what to do here. This is they're lined up on top of each other. Does that suggest to you that you're going to do elimination or substitution? What do you think? Elimination it is. So let's see you do stop and start and see what you come up with here. Okay, so I can choose to get rid of either variable. I'm going to choose to get rid of the b's, okay? And I'm going to multiply the top by negative 3 because notice these signs are the same, and when they're the same, one of them has to be negative. And I'm going to multiply the bottom by 5. So distributing across the top, I get negative 6a minus 15b equals positive 3. And on the bottom, I get 25a plus 15b equals negative 60. Adding them up, I get 19a equals negative 57. My b's add up to 0, so they disappear out of there, which is a beautiful thing. Dividing by 19, a is negative 3. Now, Let's take a look back and find B. To go find B, I use either original, must be the original equation. We call the second equations, the ones we have here with the negative 6a and 25a and stuff, we call those derived equations because you derived them after you did some manipulations. And if you somehow made a mistake between the original and the derived, you would never catch it if you checked the derived. That's why you must check the original. So 2a plus 5b is negative 1. I'm going to substitute in the negative 3 for a. So 2 times negative 3 is negative 6, plus 5b is negative 1. Adding 6 to both sides, 5b is 5. Dividing by 5, b is 1. Looking good. Now, the last thing we need to do is check this guy. Okay? Let's check in the first equation. A is negative 3, b is 1. 2 times negative 3 is negative 6. 5 times 1 is 5. That's looking good. Negative 1 is negative 1. Let's try the last equation. A is negative 3, b is 1. Okay, 5 times negative 3 is negative 15. 3 times 1 is 3. Negative 15 plus 3, you bet, that equals negative 12. So negative 12 is equal to negative 12. Booyah! We got that correct. All right, these are really good review questions. If you can get these right, you can get anything right that we're going to throw at you in this course. Okay, let's solve this system of equations algebraically and check. Make up your mind if you think this is an elimination or a substitution situation. Go ahead. Okay, doing stop and start. 7 times 4a minus 3b equals 7 times 5. And 3 times 3a plus 7b is 3 times negative 24. Why did I choose 7 and 3? Well, first off, they lined up, so it's an elimination guy. And the second thing is I already had opposite signs for the b's. So that means if I put a 7 up top and a 3 on the bottom, I'm guaranteed to match them up because in both cases it's 3 times 7, better known as 21. So let's distribute the 7. That gives me 28a minus 21b equals 35. Let's distribute the 3 on the bottom. That's 9a plus 21b. That looks so sweet. Equals negative 72. Adding them up, and I get 37a equals negative 37. Oh, this is looking good. Divide by 37, and a is negative 1. Boy, you know, there was some big numbers there. That was kind of looking ugly, but look at how beautifully that all unfolded. The beauty of mathematics. All right, next up, let's go back and find b. Use either original equations. I'm going to use the bottom one because I like the fact that the b's are positive there. So 3 times negative 1 plus 7b is negative 24. 3 times negative 1 is negative 3. Add 3 to both sides. I get 7b equals negative 21. Dividing by 7, b is negative 3. So there's your correct answer. Let's check this guy. Original equations only, no derived. 4a minus 3b is 5. Plugging in a negative 1 for a and a negative 3 for b, I get negative 4 plus 9 is 5. Yeah, that'll check. And again, plugging in a negative 1 for a and a negative 3 for b, we could also say substituting. Negative 3 and negative 21 make negative 24. You bet they do. Negative 24 equals negative 24. All right. So, you know, elimination, we got that down pat with those last two. Let's try one more, which is a word problem. Go ahead. Stop and start. Now, I thought this was a pretty challenging question because it's not as normal. Like usually you get the pizza and soda or the donut and coffee and everything is pretty straightforward. There's a subtle little given in here. Now, I wish that I had underlined the important stuff. I didn't, but I wish I had. But some of the important things here is that Pam has 2 jobs. Cashier gets $8 an hour. Tutor makes $12 an hour. And she works 30 hours, makes $268. How much time at each job? So, first thing says 8 times the amount she makes as a cashier, because it's $8 an hour, and 12 times what she makes an hour as a tutor, gives her a total of $268 during the week. And the other part, that part's pretty easy. I don't think kids have a real hard time with that. But I think the next part can be bothersome to students. And it's this stuff about 30 hours. Well, what do you know about 30 hours? She worked a total of 30 hours. How did she work? Well, she was a cashier or she was a tutor. So if I do cashier plus tutor equals 30, that's my second equation. And it would have been nice if we had another substitution to go over, but this is without a doubt easiest done with elimination. So I'm going to keep the first one the way it is and multiply the second one by -8. Keeping the first one the way it is and distributing -8 to everything in the second one, I get -8c minus 8t equals -240. Adding them up, I get 4t. Why did I say c? Oh, I need to correct that. You know how we do that, right? That has a big effect on this. 4t, so t is 7. Oop. And then that should stay c. And that should say 7. And that should say c. That's just Mr. Linquist doing something really stupid. All right, so we got to the point where we distributed the -8. So here we are. And this is looking good, right? We figured out we need to pair up the c's. We could have done 12 with the t's if we wanted to. That'd be fine. But we did the c's. So we got 8c and -8c. That adds up to nothing. 12 t's and -8 t's is 4 t's. 268 minus 240 is 28. So that gives me 4t is 28, dividing by 4. And that gives me that t is 7. That is correct. Got to go to either original equation to find the c. Now, that bottom equation looks a whole lot simpler to deal with. So c plus t equals 30. C plus 7, because the t is a 7, is 30. So that means that c is 23. And those are your correct answers. 23 hours as a cashier and 7 hours as a tutor. All right. I don't know why it's not clicking off here. Oh, because it got loaded twice. Oh, look at that. All right. Now, the last bit of stop and start right here is some review questions. All right. So you got 3 factorings to do. They're standard trinomials. No plan A, plan B guys this time. You can use the calculator or AM, and then which interval, because, you know, we never quite 100% on these interval questions. And then a consecutive integer question. So let's have you try those 3. I'll go over the correct answers with them, about them with you after we do stop and start. Okay. First one, what 2 numbers multiply out to positive 14, add up to -9, -7, and -2? You could do it in the calculator. Under y1, you would put 14 divided by x. Under y2, make super sure that's in parentheses, and then plus x at the end. Look for the last column where it says -9, and then the 2 previous columns are the correct answers, -7 and -2. I won't give the calculator explanation here, but you can follow it along for the first one. You're just going to change what goes into y1 to 12, okay? And that, of course, makes a change in y2. AM, what 2 numbers multiply out to 12, add up to 8, 6, and 2. So it's n plus 6, n plus 2. I should also, for both of these, do a quick mental check. A times a is a squared. A times -2 is -2a's. -7 times a is -7a's. -2a's and -7a's add up to -9a's. -7 times -2 is 14. For 5, quick mental check. N times n is n squared. N times 2 is 2n. 6 times n is 6n. 6 times 2 is 12. Perfect. Number 6, what 2 numbers multiply out to -35? Add up to -2. That would be -7 and 5. If you did the calculator, it would be -35 divided by x. Really wish you'd put that in a parenthesis. You don't have to, but you do have to on y2. In parentheses, -35 divided by x, and then plus x. It's so important, I think, to use the parentheses with a negative in that calculator at all times. Otherwise, you can get questions wrong that you don't think you're going to get wrong. The 2 numbers that multiply out to -35 and add up to -2 are -7 and +5. Which interval notation best represents this? Well, look, a bracket you're allowed to equal, and if you look very closely and carefully at the top and bottom of that bracket, they hide a little equal sign in there. So you can see it. So I need the -4 to be an or equal to, which means it must be choice B or choice C. And the parenthesis means you cannot be or equal to because it doesn't have an equal sign. So we're looking at letter B. Okay, next up, find 3 consecutive even integers such that the sum of 3 times the first, the second, and twice the third is 53. So the 3 consecutive integers are going to be n plus 1, and n plus 2. Oh, it says consecutive even. Uh-oh. Let me see if I made this adjustment here. I did not. Ooh. Let me go back and make another quick adjustment here. Let's hope this works out evenly. It's not going to work out evenly. I know it's not. Okay, so we're going to leave this the way it is. And what I'm going to do is change this slightly on you. Look at this here. Home and shapes. And I'm going to take this. I'm going to put it right over this. That'll block that word right out for us. And now we go back to the slideshow. Okay, so let's have you do this question from the beginning. Play from current slide. Stop and start, and you're going to do this last one, number 5. So do it over again, and then we'll check the answers on it. Go ahead. Okay, so the correct thing to do this time, we got these answers we'll go through. The correct consecutive integers are n plus 1, and n plus 2. And you get 3 times the first plus the second plus twice the third is 53. So 3 times the first is 3n. There's the first. 3 times the first, 3n. Plus the second. Okay? Not doing anything to the second, but there's the second. And then twice the third. So there's twice the third. Make sure you use parentheses. Distributing. And then I do same side, same operation. So altogether I have 6 n's there. 3n and 1n make 4n. 2 more is 6n. Plus 5 is 53. I subtract 5 from both sides. And I get 6n is 48. Dividing by 6, n is 8. So my correct answers are 8, 9, and 10. All right, here's absolute value. This is where we begin the next lesson.